In this lesson, students explore how to create, manipulate, and play musical compositions directly in a web browser using modern JavaScript libraries. The project introduces them to digital audio synthesis, interactive user interfaces, tempo manipulation, and MIDI export, all integrated into a single application. By completing this project, students gain both conceptual and practical understanding of digital music representation, interactive programming, and web-based audio processing. Students will learn how web browsers can generate sound using digital synthesis. This includes understanding waveforms and timbre, the distinction between samplers that play pre-recorded audio samples and oscillators that generate synthetic sounds, and how audio signals can pass through multiple effect nodes such as reverb, delay, tremolo, and panning before reaching the speaker. Students will also explore volume and dynamic control, learning how changes in amplitude, expressed in decibels, affect perceived loudness and how linear versus logarithmic scaling impacts audio manipulation. The project emphasizes sequencing and timing, teaching students how musical timing and structure are represented programmatically. They will understand the relationship between tempo in beats per minute and note durations, seeing how modifying the tempo proportionally adjusts the duration of each note. The system merges consecutive identical notes or consecutive rests to optimize playback and maintain precise timing, demonstrating efficiency strategies used in digital music production. Students will also experience interactive music generation. They will work with algorithmic sequences where notes are selected randomly within defined constraints, and they can manipulate the composition in real time through a web interface. This reinforces the concept of event-driven programming, where user actions trigger immediate feedback. The application includes deterministic playback loops as well as randomized looped playback that continuously generates new sequences. Through this, students learn about asynchronous programming, concurrency, and real-time control. The project integrates complex user interface design. Sliders allow real-time control of volume and tempo, buttons trigger playback and loop operations, and the interface visually highlights active notes as they play. Students learn to connect user interface events to underlying audio logic, creating a cohesive experience where visual feedback is synchronized with sound. MIDI integration is another core skill taught. Students learn how MIDI encodes music symbolically rather than as audio, allowing compositions to be exported and used in professional software. They learn to convert the sequences, including merged repeated notes and rests, into MIDI events, reinforcing concepts of data representation and interoperability between web applications and standard music production tools. By completing this project, students develop skills in digital audio manipulation, interactive programming, algorithmic composition, web interface design for musical applications, and data export for interoperability. They gain experience in combining asynchronous programming with real-time user interactions and learn to handle the temporal aspects of music in code. They will be able to build browser-based music sequences, generative music systems, interactive learning tools, and multimedia applications that rely on real-time audio and visual feedback. Students will understand both theoretical and practical aspects of music, such as timing, note durations, and rhythm, while also mastering the technical skills needed to implement these concepts programmatically. The lesson bridges web development, audio engineering, and algorithmic composition, providing a comprehensive foundation for creating interactive musical experiences entirely in the browser. This knowledge prepares students for projects in interactive media, game development, music technology, and educational applications, as well as giving them a framework for exploring creative applications of algorithmic music generation.